This video covers the Lesson 7-3 warm-up for Secondary 1 Math. Show whether or not the three side lengths form a right triangle. Number 1, 1.5, 2, and 2.5. So the first thing we want to do is identify the hypotenuse, which is always the longest length. So in this case, it will be the 2.5. So this is C. Then we're going to substitute it into the Pythagorean theorem equation, which is 1.5, in this case, squared, plus 2 squared. And we're going to see, this is a question, if that is equal to 2.5 squared. So 1.5 squared is 2.25. 2 squared is 4. And now we're going to check and see if this, it should be 6.25, is equal to 2.5 squared. And if we put that in our calculator, 2.5 squared, we get 6.25, which is the same as 2.25 plus 4. So this is a right triangle. Number 2, the side lengths 0.8, 2.1, and 2.3. So again, our hypotenuse is the longest length, so it's the 2.3 is C. Then substitute these values into the Pythagorean theorem equation. So we have 0.8 squared plus 2.1 squared. And we're going to see, is this equal to 2.3 squared? So 0.8 squared is 0.64. And 2.1 squared is 4.41. Again, I'm just using my calculator. And that's equal to 2.3 squared, which is 5.29. Now I said that is equal to. It's not necessarily equal. We're looking to decide if it's equal. Now is 0.64 plus 4.41 equal to 5.29? Well, that's a definite no. Because 0.64 plus 4.41 is 5.05. So not equal, which means this is not a right triangle. Number 3, we have the side lengths 23, 264, and 265. So again, the longest length here, 265, is our hypotenuse. Now we're going to substitute these values into the Pythagorean theorem equation, which would be 23 squared plus 264 squared. And we're going to see, is this equal to 265 squared? So 23 squared plus 264 squared. Now you could put all of that into your calculator at once. 23 squared plus 264 squared. Hit enter, and we would find that this is equal to 70,225. Now, putting 265 squared in our calculator, we get 70,225. And those are equal to each other, so we're going to say this is a right triangle. So again, number 3 is a right triangle. Okay, number 4 and 5, we're asked, given side lengths A and B, find the length of the hypotenuse C. So what we're going to do is we're going to substitute them into the Pythagorean theorem equation. Since we have a right triangle, we're finding the hypotenuse C. So we have 15 squared plus 36 squared. And we're asked to find the hypotenuse C squared. So 15 squared, we get 225. 36 squared is 1,296. And that's going to be equal to C squared. Now we're going to add these two numbers together, 225 plus 1,296, and we get 1,521 is equal to C squared. Now we need to take the square root of both sides to get C. So the value of C is 39. And then put our units on, so 39 centimeters. So the hypotenuse is 39 centimeters. Number 5, We're given a right triangle with leg lengths of 36 and 48, and we want to find the hypotenuse. So we're going to go ahead and set up our Pythagorean theorem equation. It could be 36 squared plus 48 squared equals c squared. Then using our calculator we find 36 squared, and that's 1,296. And then we're going to add 48 squared. Using our calculator we find that to be 2,304. And then we're going to add those two values together, which gives us 3,600 is equal to c squared. Now taking the square root of both sides, we get 60 is equal to c. So 60 feet is the length of the hypotenuse of that right triangle. For numbers 6, 7, and 8, we're going to simplify each radical expression if possible. No decimals, so we're not approximating. So remember, when we want to simplify radical expressions, we're going to do the prime factorization of it. So here with number 6, we have the square root of 750. So we're going to do the prime factorization. And it's nice that it ends in a 0. That means it's a multiple of 10. So 10 times 75 would be 750. And 10 will factor down to 2 and 5. 75 will factor to 25 and 3. And 25 factors to 5 times 5. So now that we have the prime factorization, we'll put that in our root and see what we can do. So we have 2 times 3 times 5 times 5 times 5. So notice that there is a pair of 5s, one pair of 5s. So we're going to have a 5 on the outside of our square root. Left inside is 2 times 3 times 5. Well, 2 times 3 is 6 times 5 is 30. So we're going to have 5 root 30 as the simplified radical expression. All right, number 7. So we have the square root 405. So again, we're going to find the prime factorization. And since it ends in 5, I know it's divisible by 5. So I'm going to do 5 times, well, I'm going to take 405 divided by 5, that's 81. And 81 is divisible by 9. So 81 divided by 9 would be 9. So notice that those are the same. I know they're not primes, okay? But I notice that they are the same. And so when I put these in my root, so if we write this as the square root of 5 times 9 times 9, we see that we have a pair of 9s in here. So we're going to get a 9 out. So we're going to have 9 root 5 as our simplified radical expression. Number 8, the square root of 320. So again, find the prime factorization. This one's nice. We have 10 and 32. And 32 will factor down to 4 times 8. Now, really, we could use whatever we wanted. I just remember 4 times 8 is 32. And 4 is 2 times 2. 8 is 4 times 2. And 4 is 2 times 2. Remember 10, we didn't factor all the way. It's 2 times 5. So our prime factorization gives us the square root of 2 times 2 times 2 times 2. Let's see, 1, 2, there's 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. I'm going to have to go another line. 6 times 5. So looking for pairs of 2s, it looks like we got 1, 2, and then we have a third right here. So that's 2 times 2 times 2, which is 8. And then we'll have a square root with a 5 inside, because the 5 is left. So our simplified radical expression is 8 square root 5. This concludes the video of Lesson 7-3 Warm-Up for Secondary 1 Math.